Okay, hi everybody, welcome. My name is Yarrow Koning. I'm one of the Manatee Masters here at Manatee Lagoon and FPL Eco Discovery Center. I'm really excited that y'all are here today, both for our Manatee Season Kickoff event and also for the relaunch of our Lectures at the Lagoon series. So we're going to be hosting lectures with different speakers, researchers, educators, etc. Generally speaking, the first Sunday of every month. This one's a little different because of our Manatee season kickoff, but generally speaking, first Sunday of every month from 2 to 3 p.m. and they'll all be free, open to the public, lots of different stuff coming up with that. So for today, we have Dr. Beth Brady with Moat Marine Laboratory. So I'm going to tell you all a little bit about her, and then I'm going to give this microphone to her. So Beth was born and raised in rural Pennsylvania and first found her interest in marine life on a family vacation. Although she initially went to school to be a registered nurse, after a few years of nursing, she realized her true passion was marine biology. She returned to school and got her undergraduate degree at Kutztown University, Pennsylvania. After graduation, she volunteered with multiple marine mammal and wildlife organizations and found her love of manatees through an extended internship at Florida Fish and Wildlife. After the internship, she completed her master's at Nova Southeastern University, where she first became involved in studying underwater sound, acoustics, and manatee vocalizations. She completed her doctorate at Florida Atlantic University in 2020 and is currently a postdoctoral research fellow at Moat Marine Laboratory in Sarasota, Florida. Dr. Brady's primary research investigates vocal communication in manatee species. In addition, she studies manatee behavior, ecotourism impacts, and recently started flying drones to assess the body condition of Florida manatees. And her talk is called, What Does the Manatee Say? So thank you so much, Dr. Brady.
Thank you so much for having me today, and welcome. Thank you for braving this weather, this interesting rain to come out here today. So yeah, let's talk about Florida manatee vocalizations and what I've learned from them throughout my 14 years of doing research on them. So animals communicate to solve problems in their environment. And there might be multiple modalities animals that use when they're communicating with other animals, but acoustic communication can be particularly important. So animals that live in turbid environments like the water parasite or live in the forest, acoustic communication can be a lot easier than saying actually visibly being able to see the animal you want to communicate with. So one of the fundamental questions that researchers ask when trying to define what an animal's vocal repertoire is what sounds do they make? And what do they mean? So one of the ways we can try to figure out how many sounds an animal might make is dependent upon the number of animals, if they live in a group or not. So for example, you have elephants. Elephants, they live in groups, right? So they have between 8 to 15 different call types, depending on the author. And those call types are used for group cohesion, identification, and mating. Meerkats are absolutely fascinating. They have 13 different call types just for each type of predator that they might encounter. So an eagle has a different call type, maybe a hawk has a different call type. 13 call types just for that. What about a rhino? A rhino doesn't have a whole lot of predators. They tend to not live in groups. They make 3 to 4 call types. So this is what we're starting to see, that animals who live in groups tend to make more vocalizations, and animals who tend not to live in groups make fewer vocalizations. And when we talk about vocalizations, we talk about discrete or graded. So what does that mean? So I want you to look at this image that I'm showing you is a spectrogram, or a graphic representation of sound. The image on the far left is what we might call discrete. So this right here, right here. Imagine that being repeated over and over and over, right? It doesn't really change much. It looks virtually the same no matter how many times you say it, right? We call that discrete. The rest of the spectrogram is what we call graded. So all these call types came from one individual animal. And as it approached its food source, you can see it got progressively and progressively noisier. Right? So is it the same call type? Does it have the same meaning? Or do these different variations have a different meaning? So I want you to think about your dog or your cat. If you have a dog or a cat, it barks or it meows. And you can tell by the way it barks or meows whether it wants food, whether it wants to go out, whether it wants to play. Similar thing with animals. They change the structure of the call depending on their behavior that they're engaged in. So this is what we think manatees might use to communicate. Well, what do we know about manatees? Do they live in groups? Well, we commonly find them in groups. They aggregate out here, right, in large numbers. But these groups are usually temporary and last maybe for a couple hours to maybe a few days at most. What about predators? All those meerkats, they made those 13 alarm calls. What about manatees? Well, manatees have some predation, some evidence of that by sharks and alligators, but it appears that once they get to a certain size, this isn't much of an issue for them. Manatees are what we call semi-social. They tend to be mostly alone. But what about their food source? Manatees are herbivores. So they don't have to cooperatively forage for food or search out their food source like a dolphin might. So what we think is manatees, this would lead us to believe that manatees would make few call types. But what about their brains? And why would acoustics be important to manatees? So let's look at the brains. This is an image of the brain, and I want you to notice a couple of different things. Up at the top, right, we have the visual cortex, really small. Do manatees have good vision? It's kind of fair. They don't have the spatial acuity that you and I do, but they can see blues and greens and some other colors. What about their auditory section though? Huge, right? Rather large. Well, this would give us a first indication that communication is rather important to them. You also might notice the somatic sensory, the sense of touch, right in here, also quite large. That's also very important to them, their sense of touch. They have hairs on their face as well as on their back that they can use to change the temperature or tides, things of that sort. The other interesting thing is a little segue here. You notice that their brains are smooth, right? Humans, we normally have ridges in our brain, and so do dolphins, usually thought to be intelligence, a symbol of intelligence. Manatees' brains are what we call lacinophilic, meaning flat. And the thought is that manatees aren't very smart. However, I would disagree. Manatees, I think, are actually quite smart. How do they remember where to go for their warm water refuges year after year and go to the same spot? Even with some of the research that they did at Milgram Laboratory, so I guess about 10 years ago, or 5, 6, 7 years ago, they taught them how to station in a tube in an area, and if they heard a sound, they had to go press a lever to hear whether or not they heard the sound. And 5 years later, they actually gave them the command to do that again, and they remembered it. 5 years later, after the experiment had ended. So that's telling me they have fairly good memories, at least, I believe they're not that unintelligent. Where do manatee vocalizations come from? So this was done by one of our colleagues. So she actually put a hydrophone on the throat and on the nose. And what she found was most of the sound energy was coming from the throat. So manatees have vocal folds similar to in their throats. And on the nasal area, why would they put it there? So when you vocalize or make a sound, your sound resonates from the vocal folds, goes up and goes into your head, and then comes out through your mouths. Well, a similar thing happens with manatees. When they produce a sound, it comes up from their vocal folds, resonates up in this frontal region. You actually can see their head moving sometimes when they're producing a vocalization. So what do we know about manatee vocalizations? Well, manatee vocalizations were pretty much in its infancy when I first started studying them many moons ago. So we know that their fundamental frequency, or their pitch, like what my voice is, pitch you're hearing my sound at, is between 2 to 5 kilohertz. And I've outlined for you there in white what a fundamental frequency is. It's the lowest frequency band in a harmonic series. The dominant frequency band, where most of the energy is, tends to be the first harmonic above the fundamental. Most calls contain what we call a harmonic structure. Imagine if you pluck a guitar, those extra sounds that are coming off are what we call harmonics. And most calls contain frequency modulation. So if you look at a call, it's not necessarily flat, but it kind of goes up and down like this. Which is kind of what I'm showing you here in these spectrograms. So we know manatees make sounds, right? They make these sounds that are tonal or more flat. They make sounds that are frequency modulated, like the spectrogram in the middle here, where the sound kind of goes up and down. And they also make these noisy sounds right here, But does that mean something different to the manatee? Which is why I started looking into that. And then I also was curious about calf and calf vocalizations. So when we age, our vocalizations change from when we're little to when we get older, right? Our voice isn't quite the same. But what happens with manatees? Do their voices change as they age too? Didn't know. We also know there's manatees all over the world, right? You have the West Indian manatee, right? So it's comprised of the Florida and the Antillean manatee. You have the Amazonian manatee. You have the African manatee. Are their vocalizations similar or different than the Florida manatee? So this led me to my research questions and the things that I wanted to know more about. What is the manatee vocal repertoire? Are their calls associated with behavior? What is the function of their calls? Do their calls change with age? And are there differences between species? So the first one I'm going to talk to you about is what is the manatee vocal repertoire. So to do this, I use a hydrophone or an underwater microphone. And that's kind of the setup that I use right there. So I'll take some electronic equipment, I'll put it into that pelican case up there, attach a hydrophone to it, put it in the water. Just an underwater microphone that records sound. So for the first part of my project, I went to a couple different sites where you commonly find manatees. So Crystal River is a warm water refuge site. It's on the west coast of Florida, which a lot of manatees go there when temperatures get lower than 16 degrees, kind of like the site right here. You have Blue Springs, another warm water site, right? And that's on the east coast, a little bit further north in the St. Johns River area. And then we have Porto Park, which is on the west coast of Florida. It's a springtime aggregation site where manatees come for fresh water. They need fresh water to drink every couple of days, so they're actually in this place quite frequently. So I put my microphone out there, and I left it out there for about 24 to 48 hours at each site. So we recorded a lot of manatee vocalization. Just to give you a general idea, at Porto Park I had about 5 to 12 animals, Crystal River up to 50, and at Blue Springs up to 120 animals. So I had a lot of manatee vocalizations to look through. So what did we find, right? So I categorized 5 call types. I first visually classified them, so I looked at similar patterns. See, do they look similar? And then I used some statistics to analyze to make sure my visual classifications were correct. So we came up with the squeak, which is this call right here, the hill-shaped high squeak, which will be really important in the not too distant future, the squeal, which is this noisy sound, the squeak squeal, which is a combination of the squeak and the squeal, and then this chirp. And I'm going to play some manatee sounds for you. Not what you probably expected a manatee to sound like, right? Very high pitched for such a large animal. So this is great. Now we've determined a vocal repertoire, but this is my interpretation of the vocal repertoire. Maybe that's not important to a manatee. So the next step, before I get into this, forget this one. We also looked at that they have their frequencies, remember I said those harmonics, they actually go into the ultrasonic frequency range, meaning outside of human hearing. Why did they do that? So the thought is that ultrasonics maybe help for mom and calf to find each other in the wild. So those higher frequencies give them a little bit more information so manatees can find one another. But the next part that I wanted to do is, like I said, I categorized those calls, but how do they use them? What is their function and what is their purpose? Are they associated with behavior? So what I did then is I went back to some of my sites again. I had Porto Park, right? I went to Harbor Branch, which is a little bit further north of here. It's in Fort Pierce. It's a passive thermal refuge. And what a passive thermal refuge is, it just maintains its water temperature just a little bit warmer than the outside waters in the lagoon. So just a couple degrees, but it doesn't stay that way for extended periods of time. I think you have a true thermal refuge. We have Crystal River. Now up there it was interesting because they have manatee health assessments every year. So they capture individual animals and they just do a health checkup on them and make sure they're okay. And then I went to Singer Island, which is really close to here, is the site that I use. And there's some seagrass beds out there, so I wanted to get some natural foraging activity. So the first thing I had to do was count the number of animals that were present and make sure that the majority of them were engaged in the same behavior. So I also did that, and I wanted to look at calf presence. Did the difference, the presence of a calf, mean that there was a difference in the number of vocalizations I saw? So how do you know whether or not you have a calf? Well, first of all, right, they're a lot smaller, and they tend to go what we call cow-calf position, meaning that calf is right behind that mother's flipper. If you also look at the video I have playing to the left or the right of that, you have some observations of nursing. So sometimes it's hard to tell if a larger calf is a calf or not. So they would be either traveling in that cow-calf position, or they would have observations of nursing like we have right there. So then I had to look at a couple of different behaviors that manatees commonly engage in. And the first one was resting. Manatees do a lot of resting. I also looked at feeding. Manatees spend about 8 to 12 hours a day feeding. We had those stress-induced calls, and we had playing or cavorting. I'm not sure that video is playing, but. So I wanted to look at those 4 different behaviors. Oh, it is playing. There you go. So cavorting is just playing that mimics mating behavior. So I also wanted to look at those graded call types. So I want to divide it into what we call high arousal and low arousal. So remember I talked about how your dog or your cat, depending on what it wants to do, it changes the sound of its bark or its meow just a little bit. Well, we actually measure that in science. Right? So we want to see if there's a difference between a high arousal state, so are they, when they're stressed, they're being captured, or they're playing, are their vocalizations going to be slightly different than when they're resting or feeding? So I divided into high arousal and low arousal states, and then I looked at it in the parameters I measured duration. How long is the call? I looked at frequency modulation, which is the one in the middle, which kind of goes up and down like this. And then I looked at entropy, or how noisy the call is. You look at the spectrogram on the far end, that's all that noise and chaos and calls. So I wanted to measure those variables. So what did we find? So we found that out of those 5 call types that I defined, manatees primarily only use 3. Really, just 3 call types. The most dominant one was the squeak. That was ubiquitous throughout. Whether they were resting, playing, stressed, or feeding, they used squeak calls. The hill-shaped call was highly correlated with calf presence. So the more calves I had, the more hill-shaped calls I had. And the squeal was kind of found, and I'll get into that a little bit when they were playing. So let's look at resting behavior. So how do I define resting? Resting, they'll tend to rest at the surface, as you see here, or sometimes the animals will bottom rest and will sit on the bottom, come up every 6 to 7 minutes to breathe, take a breath, and go right back down to where they were. And they rest in some pretty interesting ways. I love these. So again, they have these squeak vocalizations. So tonal calls would mean low state of arousal. A more frequency modulated call would mean a higher state of arousal. So do you guys think these would be more tonal or these would be more modulated? They were more tonal, right, and flat. Not a lot of modulation in their calls. What about feeding? I'm going to play this video for you. Okay, the video doesn't work, but we'll play some sounds of feeding here. Okay, not quite sure why that's working. I apologize for that. So the video, this is feeding, right? So manatee is mouthing algae off of the wall. And here we found again a lot of those squeak sounds, but they were more flat and tonal. What about playing? So hopefully this will work. We can see this video, hopefully. There we go. So these are manatees playing. It usually mimics mating behavior, where you see a lot of manatees rolling, playing with one another. A lot of tail action, a lot of movement in the water. So what we found here is they made a lot more modulated calls. And we also saw a lot more of those noisy calls. So what does that mean? right? Why do we see more of these noisy calls? So imagine your dog, and when it's growls, right? So we think this call might be an indication of a higher state of arousal. So could it be aggression? Potentially, right? We're not sure. Like if you see manatees there and they're mating, they're competing to make the other female. So potentially it could be aggression. And we have seen aggression in some animals in captive environments and also in the wild. Very rarely, but it does happen. The other possibility is just they're really in a hyper-excited state. They're playing, right? Imagine your children playing, their noises get louder, they're noisy, right? And remember that spectrogram I showed you in the beginning with that one animal getting closer to a food source? It got a lot more noisier in its vocalization. So potentially that could be what's happening here as well. What about these stressed animals? So we recorded over 110 animals, I believe, over 8 years. So these calls were very modulated, even higher than the ones that things were playing, right? And they're also a lot longer in duration. So imagine being a horror picture show, right? And you're like, ah, screaming when you see something. So they calls a lot longer in duration, a lot more modulated, right? And these are individuals, and normally individuals, what I found when they're by themselves, they don't really vocalize. And these animals were fairly vocal as we were calling them and pulling them in from the water. So yeah, they were a little bit stressed. So what we're finding is, overriding theme is manatees produce few call types, and they alter the structure of the call depending on the behavior that they're engaged in. Do calls change with age? So this is a paper we just published literally last week. So what we did, we were looking at manatees from Florida and Antillean manatees, and we were recording them at different ages. So there's 18 different, there's 12 here. We recorded 18 overall. But what I'm showing you here are individual spectrograms from one individual manatee, right? So at the top I have a Florida manatee. And the length that you see, the 128 centimeters, that's the length of the individual that we recorded at the time of the recording. So you have 128 to 205. The Antillean manatee goes from 106 to 199. So what do you see? So we're finding those hill-shaped calls are correlated with younger calves. And as the calf gets older, that hill shape starts to flatten out and become a more adult-like squeak. So why does this matter? Why do we care? So in Florida, we see these manatees really readily, right? So if you go to other species, other areas like the Antillean manatee or the Amazonian manatee, they're cryptic, they're hard to find, they don't aggregate like Florida manatees do. It's a lot more tropical environment. It's really hard and difficult to find these animals. But if you put a hydrophone in, now you can just listen to your area, right? So you know whether or not a manatee's been there. And now from this, we can determine whether or not it was an adult or a calf, right? Kind of important to know when you're looking at populations. And this leads me to, are calls different between species? So again, there's other species of manatees, right? We have the Antillean manatee, we have the Amazonian manatee, and the African manatee. Do you guys think there would be differences between species? What do you think? Yeah. Possibly, right? And here's a rationale thing to think about. So imagine we're in the United States. I bet you can tell the difference between somebody who lives in the United States and someone from England. We're still speaking English, right? But we just sound slightly different. What about within the United States? I bet you can tell the difference between someone from Maine, even someone from New York, and someone from the Deep South. We all sound just slightly different, but we all still use the same vocabulary in general. So yeah, this led us to our first study, looking at the difference between Florida and Antillean manatees. So you have a Florida manatee on the top and an Antillean manatee on the bottom. Do you guys see any physical differences between the two? Trying to keep you awake in this rainy weather.
The top one has a bigger head.
Mm-hmm.
Bigger nose, bigger nose.
Yeah. So the Florida manatee is just a little bit bigger in size than the Antillean manatee. The Antillean body size is just a little bit smaller. So this one, we just got the reviews back on this one. So we looked at vocalization between Belize, Panama, and Florida. And yeah, they were slightly different in each location. Panama was the lowest in frequency, and they think what they have there is mostly an adult population, about 20 to 30 individuals. And most of what we saw are those squeak-type calls there. Florida was in the middle. There's about 120 animals from these recordings, so a lot larger population, so it makes sense there's going to be some more variability there. And last but not least, we had Belize, which was the highest in frequency, so just slightly different across all three areas. This is just another graph showing you the representation of each of the variables that we measured and how they were slightly different across all three locations. So what about the Amazonian manatee? Amazonian manatee on the left, Florida manatee on the right. Do you guys see any differences between the two? Darker skin, for sure. What about that white patch on the belly? Yeah. So Amazonian manatees live in fresh water. They're the smallest of the manatee species. So do they make different call times? And the answer to that is yeah. They're slightly different. They're higher in frequency. So imagine a mouse compared to an elephant. A child, right? A smaller child is going to make a more high-pitched voice than a larger adult. Makes sense. So we have a smaller body size manatee that's going to be higher in frequency. And they also make what we call notes. So you see here's the Florida manatee or the West Indian manatee. They're kind of straight and kind of consistent across, but not the Amazonian manatee. They make these little notes. We think that also has to do with as they age, it tends to change how many notes they make as they age, but this really has only been investigated in one animal, so we're not really quite sure if that's the case throughout the species. Then we have the African manatee. So you have your African manatee on the left and the Florida manatee on the right. Do you guys see any differences between the two? What do you see? Right, the snout's just a little bit different, and their eyes are also just a little bit different. The eyes are a little bit more embedded. So, interestingly, my colleagues and I, we worked on this study not too long ago where they put out a hydrophone in Cameroon in Lake Assa, and really even prior to the study, there was only one description of African manatee vocalizations. That's it, just a description. So we hadn't even been described before. So we put this in this area, Lake Assa, put it out for about 72 hours, and we got a lot of manatee vocalizations, which was really exciting. So this was the first characterization of African manatee vocalization that hadn't been described before. And the year, it's interesting enough, 2021, is we're just finding out about African manatee vocalizations. But what we found is that they make some vocalization very similar to Florida and Antillean manatees. Another really interesting feature about this was we noted it was at night, mostly at night. Any indications of why this might be at night?
Can't see where they're going.
Well, one of the rationale is they're still hunted there, so maybe they just come to this area at night. But the interesting thing is we're starting to see this trend in other locations. So we're doing a study right now looking at temporal or just a time variation in the spot in Belize. We're seeing the more vocalizations at night than we are during the day. And even in dugongs, we're seeing more vocalizations at night than we are during the day. So why could that be? So in some of the observations I've seen, manatees will come into their warm water refuge during the day and leave and go out and forage at night. So maybe they're just coming in to their one location during the day and going out foraging where these areas are located to leave at night. Possibility. We still need to look into this a little bit more. It's still intriguing that we're seeing these same things across species. So again, last but not least, I also looked at vocalizations across cats. So this is the other publication we just did. It's looking at Amazonian, Florida, and Antillean calves. And are they similar across species for their vocalizations? So here I'm putting it all together for you and showing that the Amazonian calf, even though it's really small at birth, and so are the other species, they still tend to be higher in frequency even at birth. And the Antillean and the Florida manatee are relatively similar. So this is interesting. Why? Because Florida manatees and Antillean manatees, they grow really fast from a young age. They go from 65 pounds to almost, 300, 400 pounds in their first year, where Amazonian manatees tend to stay small from birth and continue to stay small. Their growth spurt is much shorter. So it makes sense that these Amazonian manatees are going to be higher in frequency over time. So we also did what we call playback experiments. So I wanted to play sounds to manatees to see what's important to them, right? And I also wanted to know if there was a difference between males or females. So if I play female sounds to a male manatee, do you respond differently if I play sounds of a female to you? What about if it's the call type? What if I play that tonal sound or that noisy sound? Does that make a difference to you? So we did some of this work in Mexico, where they had a group of captive female manatees in one spot. And we also did it in another pool there. These are another group of female manatees. This was really interesting and a bit of a challenge because you can see they're surrounded by dolphins. So in this pool, we got this. Now this is interesting because this is not anything manatee. These are all dolphin echolocation clicks from this pool. So we didn't really get any data there, but the interesting part about that was we were learning, well, maybe all this noise maybe not be good for a manatee since they're in this environment. But I do want to show you some of the results of this experiment. I'm going to play you a video from the playback experiment in Mexico. This is 30 seconds before playback of the sound.
Bonbon is feeding, mother and calf are resting and traveling slowly. 7, 6, 5, 4, 3, 2, 1, playback. Rapid startle response from Dorothy. No other singing response from the other animals. Dorothy kicked her tail and swam away. She's now doing spirals by the edge.
So that's just one example of what we found. We got a startle response, and then some of the other playbacks we did, we found that when we played the sounds, they got really intrigued by the sound and started turning and going towards the speaker to investigate, right? They were very interested. They also tended not to vocalize that much more. For some of the literature that we do have, manatees tend to vocalize when they hear the sounds of other manatees. These ladies didn't. They were interested in more turning and focusing and investigating where the sound was coming from. So we also did this in Florida. Oops, I do Oops. So we also did this in Florida with Hugh and Buffett. So over in Sarasota, I worked with 2 resident male manatees. So we wanted to do the same thing with them. We wanted to take the same sounds we played to the animals in Mexico and play it to Hugh and Buffett to see, do they respond differently to male and female sounds? I'm going to show you some video from that. Three, two, one. Playing sound at 26:16, and played sound. Hugh is still, he's still sleeping on the shelf. He could have cared less. Continues to rest and sleep. So yeah, the interesting part with these guys is they didn't care what I played. They didn't move. It didn't matter if I played a squeak, male or female, and we're still looking at some of this data. But no matter what I played, they never turned and oriented towards the speaker. So we're not quite sure if this is really, since they're a rather small tank, if that's the situation or if there's something else going on there. However, this led to a really fascinating discovery, and I'm really excited to show you this, because this is really unique for manatees. So this is the really exciting discovery that we found. Manatees make clicking sounds. So, these are dolphin echolocation clicks. The echolocation clicks are really important for dolphins as it helps them navigate and find food, right? And usually it's thought that this is limited to bats, dolphins, and some type of birds. Now we're finding that the manatees. The manatees are making clicking sounds. Why are they making these clicking sounds? They actually clicked more than they actually vocalized, and a lot of clicks. So what are they using it for? Now, it's not the same as a dolphin. They're not making really a rapid succession of clicks. It's click, click, right? But why? So in other species, like humpback whales, they actually make clicking sounds when they're foraging, not this rapid succession either. And I also want you to think about humans. Humans can echolocate. If you click your tongue and keep doing that, determine whether or not something else is in the room. So there's potential for this, and we're going to design some experiments around this, testing manatees at night, maybe putting more obstacles in their environment, or actually blindfolding them since we have a permit to do that, and see, do they click more when you take away their sense of vision? Because human buffer in this really clear tank, right? So if we take that away from them, will they click more or less? Are they using these clicks as a rudimentary sense of echolocation? Who knows? It's really exciting, right? Figure out. So I also do some work on, like I said earlier, anthropogenic noise impacts on humanity. So this is some work that some colleagues and I have done in Mexico. And we really have very little information about what kind of impacts that we have with ecotourism on manatees. So let me show you some of the video that we got from Mexico using drones. So manatees in Mexico, they are what we call resting holes. And these are areas where they go to for fresh water. And right there, you can see a group of manatees. Over here, you can see a group of manatees. And these are all images we took from the drone. So they come to these resting holes during the day to get fresh water. They usually stay there throughout the day, and then they'll leave at night, presumably to go forage for food. This is a really beautiful area to take some of this drone video from. But this is also a popular place for ecotourism in Mexico. So in Mexico, tourists come to this area and it's their form of income. They take people out for tours to look at dolphins and manatees. And let's see some of the behaviors that some of these tour boats behave. What they do. So now you have 4 boats surrounding a cow-calf pair. This could be potentially stressful for the animal, not from noise, but you're also crowding these animals. Right? So this is just one occasion, what we saw when we were out there. So we were out there for 10 days. We flew our drone monitoring these interactions. And I have one more video to show you. So that's 4 boats. Now here we only have 2 boats. Cow-calf pair in the middle. Now they're pursuing that cow-calf pair. They're keeping that pair right in the middle of the boat area. So we're finding that some of these tour boat operators, we need to educate them a little bit better on how they're going to interact with manatees. There are some tour boat operators that sit back and they just turn off their engines and they allow the manatees to be manatees. And some tour boat operators are what you're seeing here. They're pursuing them, they're surrounding them. We also looked at some of the vocalizations they make, and they're pretty much silent when the boats are there. They stop communicating. They start picking up communicating after those boats leave. And last but not least, this was one of the favorite papers I got director, right? So you know elephants are their close relatives, right? So we did this recent paper, we looked at elephant vocalizations compared to manatee vocalizations. And when you see the comparisons, they look really similar to them. At least I think they do. But yeah, manatees and elephants have a lot of similarities with one another. Elephants actually, their vocalization is about 20 hertz, which is outside of the range of human hearing. They're very low in frequency. It makes, like I said, there's something that you can hear if you're in the water with them. And that's because elephants are on land, or land animal rights, so they have sounds that are going to propagate and go a lot further. Manatees, if they produce that type of vocalization in water, you probably wouldn't be able to hear it or wouldn't propagate very well. But that's the crux of my work, and there's obviously still more work that needs to be done and new exciting discoveries we make, even with a playback experiment that went quite differently than what I actually expected. So we're finding some really interesting things about manatees now that communicate with one another, which I'm really excited about moving forward. So thank you for being here with me this afternoon, and I'm happy to take any of your questions.
How did you know that they stopped communicating when they were, when boats were around? Did you have a microphone in that area as well?
Yeah, we had a hydrophone out there the whole time we were out there, and then we left one out there for 24, it was in the water for 7 days straight. So we looked at the noise levels that they were exposed to. So imagine being at a rock concert for 8 hours, and after you leave, your ears are ringing, right? That's what we call a temporary threshold shift, meaning you have temporary ear damage. So what happens to a marine mammal when they're surrounded by noise for hours and hours and hours? Right? And those animals are exposed, when we look at the recordings, for at least 8 to 10 hours a day, they're exposed to boat noise. They're boats either traversing the area or they're coming up specifically to look at the manatees. Now, it's not at a loud enough level to cause temporary hearing damage, but it is loud enough to affect the communication. So we could see that there was more vocalizations after the boats left, and there were no vocalizations when they were present, which means it's meant to impact. And if you see the cow-calf pair, they communicate most frequently with one another to stay in contact. How is that interrupting and working with them, right? How, if you separate a cow-calf pair, that can mean the death of the calf. So it's something that's very important for us to learn about how it's affecting their communication, since it does appear to be so important to them.
And one question too,
Sure.
which is what has something to do about the hydrophones, that I'll come back to.
It's okay. Anyone else have any other questions? Yes?
The one that didn't seem to respond to the, I think it's the male, when we put it in the tank.
Mm-hmm.
Do you think that that can have something to do with it? In other words, it's like bored, it's like you probably
Yes.
heard all kinds of noises before.
Yes.
He has nothing to fear, nothing to forage for, because it was actually in a tank.
Yes.
So therefore, when he hears noise, it's like, he's totally turned off.
Yes. The short answer is yes. We think that might possibly have something to do with the lack of response that we got. And it also, like, right, exactly. They've been in that tank for a long period of time. You and Beth have been there, I think, 3 years. And because of that, and because of this experiment, we're actually designing some other experiments around that. So animals sometimes in environments like this, they know what you call stereotypical behaviors. So sometimes we were playing sounds and Hugh kept going in a circling motion because he was waiting to get fed. So sometimes it's okay, it's an indicator of health, and if you vary their feeding times, they can get really stressed out. But we want to reduce some of those anticipatory behaviors, is what we call. So how do you do that? So in other captive areas, they play music. So we're like, well, maybe we should play music to Hugh and Buffett. And since their namesake is Jimmy Buffett, we thought we should play some Jimmy Buffett to Hugh and Buffett. So we were designing some experiments around that, not just playing music, but we're playing some other manatee sounds a little more frequently, maybe some natural noises that they hear in their environment, just to see if we can reduce some of those stereotypical behaviors and just see what they're going to respond to. But yeah, we do think the captive environment probably have an effect on their vocalizations.
I remember the other question, the clicking thing, is that just a recent discovery that they click?
Yes.
Wow.
This is just recent. This is just, the interesting thing was they thought, we noticed that there was some literature talking about clicks, but I always just discarded it because there's a lot of ambient noise in the environment. Snapping shrimp makes something look really similar to a click. So how would you identify that from a manatee as opposed to a snapping shrimp click? Really hard to discern that. But we started looking into this a little bit more and finding like, okay, there's nothing else in this tank that could be producing that sound. It's not the filter, it's not the fish. What is it? It's coming from the manatee. So we're like, okay, this is really cool. Why are they clicking? And what are they using it for? There has to be some kind of purpose. So that's where we're designing some experiments around that. Any other questions? Well, thank you all. Oh, sorry, go ahead.
Just a quick question. You can answer this. How are you doing with those? I know we lost so many of them last year because of loss of food for them. How are you doing? Are you aware of what's happening at this point in this area with the feeding of the manatees?
So they're going to be feeding the manatees again this year. So let's think about it this way. We don't normally recommend feeding any animal in the wild. So if you're feeding an animal in the wild, it must be a pretty dire situation. So last year, and I didn't touch upon this, we actually flew drones over in the Indian River Lagoon looking, trying to look at the body condition of these animals and see what the overall body condition of the population was. And we're still trying to refine those methods because an animal on land who looks emaciated may not look the same as in the water because the water kind of holds up. But you can see really, really skinny animals and they are picked out really well with the drone. So we're working on that. Hopefully we'll be doing that again this year. How are they doing? Hard to say because I don't think they've done, I think FWC has done some abundance estimates, but I don't think they've come out with their numbers yet to see what the minimum estimate of the population is. Every time you see the abundance surveys, they put up the numbers of their synoptic survey. That's the minimum number of animals that they counted, not the population itself. So I think they're having a really rough time, and I think, my opinion is they're going to be taken off the threat list and upgraded to endangered, or downgraded, I should say, to endangered. In the not too distant future, whenever that takes place. But it's going to be rough out there until we heal or take care of the problems in the Indian River Lagoon. It's going to be a struggle. Yes? Thank you. Thank you for your time. I appreciate it. Thank you. Have a good day.
Thank you so much, Dr. Brady. I think everybody really liked your talk. I liked the pictures of the manatees resting also. So yeah, thank you all for coming. And again, this is part of our lectures at the Lagoon series. We will be having another lecture in December. The one in December will be on December 11th, and we are going to be having Samantha McGuire, the Outreach and Marine Education Specialist from FAU's Harbor Branch Oceanographic Institute. She's going to be talking about dolphins and specifically about citizen science projects around dolphin spotting. So y'all can find out more information on our website, visit manateelagoon.com. Registration is encouraged, and you can do that on our website as well. So thank you all so much. Maybe we can give Dr. Brady one more round of applause.